My project is Brewing Nanoparticles. My two mentors were Professor Yukar and Professor Mady. So the point of my experiment is to use coffee as a replacement for reducing agents and stabilizers when you're creating nanoparticles. So a little background on nanoparticles. Usually you have to take a metal salt, a metal ion, like silver nitrate, something along that line, add a reducing agent that will reduce the metal ion down to pure silver, and then add a stabilizer that will keep the atoms from actually aggregating into just one big old clump. The typical way of making nanoparticles uses highly dangerous materials. The reducing agents are usually corrosive. It also uses some thermal input to catalyze the reaction to happen. And now coffee is an inexpensive option that will actually produce nanoparticles without using any thermal input, and the actual reducing agents in coffee are not going to be corrosive. They're strong enough to act at room temperature, and you don't need to add any extra stabilizer into the reaction. So my objective is to explore brewed coffee as an alternative to the current procedure for synthesizing nanoparticles. My hypothesis is that if we use coffee as a replacement for the current procedure, we'll get the same results or similar results. So the actual point of my project will be at the end to characterize the nanoparticles that are actually synthesized and compare them to nanoparticles that were synthesized in the typical way. So my methodology, I plan to conduct this experiment in our labs. I know that we have the nanoparticle salts to use, and then all I have to do is get coffee, because it's a reaction that occurs at room temperature. If available, I would like to test it on more than just silver. I know we have gold. I don't know if we have palladium, but if we could actually use this as a method for synthesizing nanoparticles, this could be done on a very large scale as a replacement to doing smaller reactions. My one concern is that the coffee synthesis may not produce uniform nanoparticles. There's been one other experiment where this has been done for silver nanoparticles only, that the particles came out at a range of 20 to 50 nanometers. So that's rather large on the nanoscale. And if they come out in such a big range, it's harder to use those nanoparticles because you need to have nanoparticles tuned specifically to a certain size. The relevance of using this, nanoparticles obviously have unique properties, optical, thermo, and electrical properties when they're that small. The nanoparticles now are being used in anything between solar energy and curing cancer. So there's a very, very wide range of opportunity here. Any improvements to the synthesis of the nanoparticles, like the actual procedure, could be an improvement to the field as a whole, because nanotechnology is an emerging field right now. And then my references. Anyone have any questions?
All right.
Yes, I have a question. Would you, in a few words, explain to me the mechanism by which you would carry out the coffees? You may not have my coffee, but how the what is the mechanism of the process?
So basically, like a reducing agent, like ethylene, it's like an alcohol. The reducing agents in coffee are believed to be polyphenols, which is carbon-chained alcohols in the coffee. So the reason why, or are you just asking for like the medium that it will be done, carried out, or the actual chemicals?
I'm not quite clear how you go from I assume your goal here, and you correct me if I'm wrong, but that you add the metal salt to the coffee.
Yes. Like coffee, certain measured amount, 200 grams of coffee in a certain amount of milliliters of water. And then
there's
take-
sufficient reducing, a sufficient concentration of a reducing agent
Right,
in the coffee.
right,
Will then lead to the precipitation of the nanoparticle.
yes. Yes, at room temperature.
I'm going with glucose with iron nanoparticles. Glucose versus sodium borohydride. And the glucose works, the sodium borohydride works better. But
Right. Sodium borohydride is extremely corrosive too. Yes.
So if you could maybe, next time, provide a formula for the functional group of in the coffee, the stuff in the coffee, and then tell us what the functional group is providing the electron. That's what reducing agent does, right?
Right.
So put some technical information in there.
Okay.
To make it better. And my second question would be, how do you define success in this? Like, is it making the nanoparticles itself, or is it just making monodispersed nanoparticles? How do you
I mean,
say, I did a good job in this?
I would consider it success to produce nanoparticles in a reproducible way. So if I produce nanoparticles that are 20 to 50 nanometers in size, but I can produce them over and over again in the same way, I would consider that a success. If I can produce monodispersed nanoparticles, I would sell that to somebody. Because obviously monodispersed nanoparticles are much more important. Now the polyphenols that are in the coffee, that is just speculation at this point. I've only seen one other experiment done like this, and they speculated that those chains are what the reducing agent was in the coffee. So that might also be a focus of actually determining what is the stabilizer in the coffee compounds and what is the reducing agent. Because I've only seen that it's been performed once. He had a question first.
This is, if you're gonna call it a green process, you have to be very mindful of your coffee source. Because coffee is it's a farmed crop, and the process, like any farmed crop, can either be very dirty or it can be very clean. Especially so with coffee, because it's such a lucrative and profitable crop. There's a lot of people who want to get a lot of it grown faster, and so they use a very environmentally destructive process. And there's other people who will use a more effective and actually overall environmentally more beneficial process too. So you have to be very careful about where your coffee comes from.
Okay.
Yeah, and mine is kind of relevant to that. Mine is more of the species of your coffee, because that's why your coffee tastes different, is because the beans that came out of that is basically different. So you can have different type of phenols that are actually associated with your specific kind of coffee. And so, which is really good, because this is now where you're gonna have a lot of varieties and testing and see, which is why it's very difficult to model this to start with, because your different coffee will have different phenols in there, or amount of
Right.
this and amount of that. So, but it's good to start with getting literatures that already have, generally what is in coffee. And it's not a matter of how many phenols is actually in there, standard, that's why it's coffee, right? And then you can now change different types and see, and maybe it will have some bearing on the type of nanoparticles that you actually produce based on the coffee that you use. So there's your type of coffee, and there's your recipe, right? Your step-by-step, how much, temperature are you gonna use basically on
Right.
this in the process. I think
Yeah,
that's
I mean-
you
essential.
have Arabica nanoparticles or Robusta nanoparticles?
Mhm.
Right. Well, the coffee would be what gets changed, the concentration of the coffee itself and the type of coffee used.
Yes.
And I recommend one thing that would really help, this is a slide, chemistry of coffee.
Yes. Yeah, you have to have a slide of that, yeah, especially in your poster, because that's the catch there, like Dr. Yukar is saying. It's like, you're educating immediately the baseline, why is coffee used, right? So, I think it's great. Thank you.
Thank you.